We'll go to trace of a matrix. See, trace of a matrix means nothing. If I have, what is that? If I have a matrix, if I have a square matrix, obviously it's for a square matrix. If I simply add the leading diagonal of the square matrix, just add them. Okay, 4 plus 3 minus 2. If I just add them, that is going to give me trace of that particular matrix. Okay, that particular matrix trace. 4 plus 3 minus 2, that is going to be trace. It's a very straightforward one. Okay, so nothing more specific about this. Okay, next. Addition and subtraction. Okay, before that I need to go for transpose and then addition. Okay, you guys know actually transpose. What does it mean by transpose? See, we will just ask because these are very basic, so I don't want to explain it. You will be able to answer it. Transpose, na? I just need to interchange the rows and columns. Row should change to column, column should change to row. Then it is going to be transpose. And was there any requirement transpose should be applied only for a square matrix? Not required. Even for a rectangular matrix also I can apply transpose. Okay, so the rows and columns should be interchanged. Generally we will use A transpose, this symbol. Okay, generally I will be following this symbol A transpose, but sometimes we can use any of this one symbol also, A tr or A dash. A dash sometimes use பண்ணுவாங்க, but A transpose the most commonly. So the first row will get changed to first column, the second row will get changed to second column. Okay. Next, properties. I think these things you know. See, just take this itself. I have applied transpose for A matrix. What if I again apply transpose for this? It will become A. Okay, so A transpose, the whole transpose will become A itself. Okay, and these are basic. A plus B whole transpose is A transpose plus B transpose, A minus B whole transpose. And this one you need to note down a little different. AB whole transpose will be equal to B transpose into A transpose. That's abde maathirno. Idu B A whole transpose arunda A transpose into B transpose. ABC whole transpose will be C transpose B transpose A. Regarding inverse we will discuss later, but as of now A transpose the whole inverse will be equal to A inverse whole transpose. Just keep that property in mind. See, coming to linear algebra as concerned, the one thing which you need to very what is that? You need to keep all those things in your fingertips is properties. Okay, we are starting with the first set of properties for transpose. Similarly, we have properties for inverse, we will be having properties for determinant, properties for rank, properties of eigenvalues, properties of eigenvectors. So, this ellame vandu ungaloda fingertips la irukano. Okay, if you know the properties well, you will be able to answer. If suppose a question is going to take 2 minutes to answer, you will be able to answer the same question in 30 seconds. Okay, avlo periya difference varum properties olunga therinjirundha eduthone oru question paathone okay indha property na use pannanom ungalku strike aiduchina and the question oda time vandu literally as I said 1/4 da ungala reduce panna mudiyum. Okay, if you know the properties well, otherwise it will consume more time. Okay, that is regarding transpose. Okay, what is symmetric matrix and non-symmetric matrix? Maybe I will write down. Symmetric and skew symmetric, not non-symmetric, skew symmetric. Any ideas? A transpose will be? If it is symmetric matrix, then our A transpose should be equal to A. If I apply transpose for the particular matrix, then that should be equal to A itself if it is symmetric. Listen. This actually indirectly concludes something. Which one? A transpose. It has to be square matrix because it has to be a square matrix, that is correct. But the symmetric matrix indirectly concludes something else also. They say that it is symmetric, right? It indicates your diagonal element will act like you can consider that your diagonal elements will act like a mirror. Okay, so the element which is below the diagonal element will be symmetric to the element which is above the diagonal element. Okay, so what does it mean? You can take diagonal element, it doesn't matter whatever diagonal element you take, 3, 4, 7. Okay, and these elements which I am going to take it as -2, 3, maybe 4. Okay, then the element which is symmetric to it, this second element should also be -2. if this is 3, then this should also be 3. If this is 4, this should also be 4. About this principal diagonal element, each and every element should be symmetric. Okay, if I able to form a matrix like this, that matrix is called a symmetric matrix. Okay, and there is no condition. The only condition is our leading diagonal element should be real number. Complex it has to be real. Yes. Value same -2 na -2, 3 na 3, 4 na 4. Okay, so what is this element? This element, if I represent it as 1, 2, 3, 1, 2, 3. This element is A21. This element is A12. So A21 and A12 should be same. So what is our elementary condition? Aij is equal to Aji. Very, very important condition. Okay, so first is, this is my A matrix, right? You check panni parunga. A transpose apply panna enna varudhu? First row change it to first column. Okay, it is going to be 3 -2 3. Second row second column. -2 4 4. Third row third column 3 4 7, right? So my A and A transpose now are same, and see, this kind of if my A and A transpose should be same, then Aij and Aj should be same. This same arna same condition. Okay. And as I was saying about leading diagonal element edo or real number okay. It can be equal real number 3 3 3 4 4 4 5 5 5. It can be -2 -5 -3, or it can be 0. A leading diagonal element can be equal or it can be 0. The only condition is it has to be real. Okay, then it is if the leading diagonal element is in that way and Aij is equal to Aji, it is what is that? It is symmetric matrix. Okay, coming to skew symmetric matrix. What about skew symmetric matrix? Your A transpose should be equal to it is minus of A, or A should be equal to minus of A transpose, whatever. Okay, see here also the same thing. What is that? I have taken leading diagonal element, let us suppose. About this leading diagonal element, that is, your leading diagonal element should act as a mirror, but the sign should change. For example, if our A21 is -2, if this is 3, this is -4, then this will be 2, this will be -3, this will be 4. Okay, right? So -2 it is going to be 2, 3 it is going to be -3, -4 it is going to be 4. Okay, but there is a condition here, condition for skew symmetric matrix. The condition is the leading diagonal element should be strictly which color I want, and the leading diagonal element should be strictly 0. So leading diagonal element kandipa 0 ah irundhaganum. Adu 0 ah irundha dhaan enala indha condition obtain panna mudiyum. If my A transpose should be equal to -A, my leading diagonal element should be strictly 0. For symmetric matrix, that condition is not required. Your leading diagonal element can be any real number. Okay, here it has to be strictly 0. What if it is non-zero? I mean, if it is non-zero, what will happen? The sign change will affect us. Okay, for example, this is my A, right? What is my A transpose? 0 2 -3. Next, -2 0 4, -2 0 4. Next 3 -4 0. If I multiply minus here, minus of A transpose, what will happen? 0. This minus sign, the multiplication of minus sign is not going to affect my leading diagonal. Enoda leading diagonal affect pannadu. So minus, it will become 0. This is going to be 2. That is going to be -3. This is -2 0 4. This is 3 -4 and 0. Ide enoda leading diagonal elements. If my leading diagonal elements are not 0, okay, if my leading diagonal elements are not 0, when I multiply minus sign and our leading diagonal element change it. So that is an issue. Okay, any doubts here? Skew symmetric and symmetric. The example idhula irukku, example e kuda eludhikonga, doesn't matter. Okay, And regarding elementary condition, Aij should be minus of Aji. Okay, for all, this V sign indicates for all I comma j. Center 0 are compulsion. Here it is. It doesn't matter. Aij, see, Aij is equal to minus Aji. Note center 0. So obviously, when that's specific mention it is Aii. Okay, or else what is that? When I and j are same, Aii. Now I specific mention in the condition still gets satisfied. A still gets satisfied. Aij it will be 0 minus of Aji, which will also be 0 if I and j are same. Okay, I and j are same Aij 0 Aji 0 so 0 0 minus multiply affect agadu. You specific mention doesn't matter. Is equal to 0 for all I is equal to j taniya mention panikalam. Okay, I can copy. Yes, yeah, I will complete equivalent also. Equal matrix okay, then you can copy. That will be the last two matrix. What is equal matrix? See, corresponding elements should be same. Okay, corresponding elements should be same. Here, A11 in my B matrix A11, they are same. A12 and in my B matrix A12, A21 B matrix A21, A22 in B matrix A22. So if my corresponding elements in A and B are same, then it is going to be equal. Okay, and there is one more which is equivalent. Now what is equivalent matrix? Or else I will do one thing. I will just write down here. Let me take just 1 second. B is equal to so B is 5732. A is the same matrix. B is 5732. Okay, B is 5732. Obviously these two are not equal. They are not equal matrix. Why they are not equal matrix? Because my 2, this is 5. Here 7, here 3, here 3, here 7, here 5, here 2. They are not equal. But these two are equivalent. Why it is equivalent? Just take A matrix. Just take A matrix, which is equal to what? 2, 7, 3, 5. This will be equivalent to what? This will be equivalent when I do any row exchange or column exchange. Just do some row exchange or column exchange. For example, here, let me exchange this 2. So this become 3, 5, this become 2, 7. That will be equivalent to, just do the column exchange, 5, 7, 3, 2. So in the mari ethana thara venalum pannalam. Any number of times if you do row exchange, column exchange, the final matrix which I am going to get will be an equivalent matrix to our initial matrix. Okay, so enoda B matrix na eppadi obtain pannirken? Matrix B has been obtained by doing one row exchange and one column exchange. Modalla oru row exchange, then one column exchange in order to obtain matrix B. So matrix A and matrix B are equivalent, they are not equal. Okay, I have that example anyways. Here, the same one. Okay, 2, 7, 3, 5, we have exchanged the row and we have exchanged the column. Okay, so A and B here are equivalent. Okay, value decomposition you will see through problems. Okay, first copy this. From where? Here, singular, non-singular or trace. Yeah. Okay, what about addition, subtraction? Any condition addition, subtraction pannona rendu matrix. If I want to add two matrix, the condition is B. Both of them should be of same order. Both of them should be of same order. If they are of the same order, I can add them or I can subtract them. Okay. Condition is both of them should be same order. The procedure is A11 should be added to B11, A12 should be added to A12, B11 should be added to A21 should be added to B21, etc. Okay, the condition is the particular element should be added to the same if I am going to add it. Okay, if the particular element should be added to the same. If I am going to subtract it, the same way the corresponding element should be subtracted. The condition is the order should be same, it is not mentioned here. It is. If it is of the same order, then I can do. Okay, it's again very basic one. Basic idea, addition of the matrix and subtraction of the matrix. What about this? This is also same difference. Okay, what about the property? There are some properties. This is the second set of properties, but these are not very important. Okay, important properties appadina transpose, inverse, determinant, rank and eigenvalues, eigenvector. In the 5 set of properties are important. These are okay, you can have an idea, but not very important. Okay. Associative property, you know, A plus B plus C or A plus B, then if you add C, they are going to be same. Commutative, A plus B, that should be equal to B plus A, then it is commutative. These are like what? These are very simple, basic school level properties. Scalar distribution means this K is a scalar value, okay, some scalar value. If I multiply with A, what will happen? Or a scalar 2, for example, 2 eduthu na matrix A oda multiply panna enna agum? At each and every element I need to multiply. Okay, that will be little bit different when I go for determinant. Okay, so it is going to be different in determinant, you will see that later. But for matrix, each and every element should be multiplied. Okay. And if I add a null matrix, the 0 is a null matrix, right? That is going to give me the same A. And if I add a matrix B, and if that becomes 0, then B is called as additive inverse. B is additive inverse of A, or A is additive inverse of B. Renduthayum add panni the 0 achuna. Okay. And similarly here 0 is additive identity, because I am adding matrix A to 0, which gives me that matrix itself, it is additive identity. Okay, so 0 is additive identity, B is additive inverse. Any doubts here? I believe there is nothing. What about matrix multiplication? When I should do matrix multiplication? It will be there, but still. What is the condition? It should be? Not necessarily. Not necessary. Yes, if suppose I have a matrix P, okay, M cross N, and if I want to multiply with matrix Q, then here, okay, I think I need to change this. Here the number of columns in first matrix should be equal to number of rows in the second matrix. This can be anything, NP, it can be anything. That is, number of columns can be anything, but number of columns in first and number of rows in second, both of them should be same. If they are same, then I can do the multiplication. Then I will able to multiply it. Number of columns in first and number of rows in the second one. It is anyways there, it will be displayed. Number of columns in the matrix 1 should be equal to number of rows in matrix 2. So if I am going to multiply A into B, not necessarily these two should be same. Idhum same arukonu avasiyam illa. Okay, not necessary. It can be anything. It can be square, it can be rectangular, doesn't matter. These two should be same. Okay, if they are same, then I can do the multiplication. How I will be doing the multiplication? Just take the first row, multiply with the first column. First row, first column. Okay, first row, first column. It is what I am doing 1 and 1, right? First row, first column. Multiply them. That should occupy your A11. Okay, that multiply panni A11. Multiplied product la A11 la vandarum. So 1 into 1 plus 2 into 0 is 0 plus 3 into 1 is 3. So 1 plus 3 is 4. Okay, that will be your first one. And next, first row, second column. That should be in A12. And similarly, first row, third column, that should be your A13. Similarly, I need to do. Okay. Next, I need to take second row, first column, second row, second column, second row, third column. Similarly, third row, first, third row, second, third row, third. Okay. Right. Again, these are also basic one. Here it expand panni irukku, neenga odara check panni paathukonga. Okay. Okay. What about the properties? Multiplicative properties. Same associative property. A into BC will be equal to AB into C. But commutative, it is going to be little changing here. Sometimes my product will be commutative. AB will be equal to BA, but sometimes it won't be. Okay, so in the property, may or may not தான். AB may be equal to BA or it may not be equal to BA. Just keep that in mind. Okay. Distributive property and all, it's fine. Just I am taking this A inside AB plus BC, and again the same way, scalar multiplication. I can just multiply the scalar only with one matrix. ஒரு மேட்ரிக்ஸோட மட்டும் மல்டிப்ளை பண்ணிட்டு அதுக்கப்புறம் நான் இன்னொரு மேட்ரிக்ஸோட மல்டிப்ளை பண்ணிக்கலாம். Okay, that can be done. Multiplicative identity. We know this, right? Take any matrix, multiply with an identity matrix, that will give that matrix itself. Any matrix, multiply with the identity, that will give the matrix itself. Multiplicative inverse, we have not yet discussed about inverse, but here let us consider I am taking a matrix B or matrix B in or matrix A. When I multiply those two matrices, if it gives identity, then B is called as multiplicative inverse of A, or A is called as multiplicative inverse of B. Okay, these two are multiplicative inverses. If I multiply them, if it gives I, then one matrix is called as inverse of other matrix. Okay. Generally we will use a symbol A inverse. Okay, here B is equal to A inverse. As of now we have not started how to find out A inverse. We have not discussed. I think that's it. Addition and subtraction. Problems we will see all together. Okay, we'll see all the problems all together. First copy this addition subtraction. Addition subtraction தான ஸ்டார்ட் பண்ணேன். Okay, LU decomposition, symmetric லாம் அப்புறம் பார்க்கலாம்.